All right, so this is the solutions to the circuits practice 5585. Unfortunately, I forgot to bring home a copy of it, so I'm going to have to just fill this out as we go along. And I need to pull it up on the internet to be able to see it. So give me 2 seconds. All right, the first question says, compared to insulators, metals are better conductors of electricity because metals contain... So the big thing, the difference between a conductor and an insulator, conductors have way more free electrons. So those electrons can move around much more freely. They give up those electrons. Insulators, I'm going to work on my writing in a second here. Insulators, those electrons are sort of stuck a little bit more. So the big deal here is how freely the electrons move. So the answer is C. Second question says, I don't know if you guys see that wrist guard that I just pulled up there. It says a charge of 5 coulombs. So when I'm writing this down, I'm going to say Q is 5 coulombs. Goes through a circuit in a time of 0.5 seconds. And they want to know the current. So the current is I, is just how much charge flows per given amount of time. It's a delta Q. So really this is pretty simple. It's 0.5 divided by 0.5 seconds. A coulomb per second is an amp, and 5 divided by 0.5 is just 10. So 10 amps. Did I do that right? Why did I circle? So on my solutions, I circled C, but the answer is B in the margin. So I have no idea what I was doing when I circled 5. Sorry. The next question says a current of 3 amperes. So I'm going to say I equals 3 amperes is flowing through a circuit. How much charge, so they want to know Q, passes through a given point in the circuit in 30 seconds. So T is 30 seconds. So it's the same equation that we used here. So I just want to solve for Q. So I times T is equal to how much Q flows. So it looks like, what is it? 3 amps times 30 seconds equals 90 coulombs. All right, let me erase this, and I'm going to change colors because this green is awful. We'll go with blue, see if that's any better. All right, so we're on question 4 now. Current traveling from the cathode to the screen in a television picture tube is, so obviously an old question because we don't use cathode rays and picture tubes anymore. We use LEDs or OLEDs or QLEDs, depending on how sophisticated you are. So this is super old, but whatever. They tell you that I is equal to 5 times 10 to the negative 5th amperes. And they want to know how many electrons. They want to know the number of electrons strike the screen in 5 seconds. So the equation we want to use is I is Q over T, but Q is the charge in coulombs. That's not going to tell us the number of electrons. Well, not directly at least, but we'll go with that first. So Q is equal to I times T, which is 5 10 to the negative 5th times 5, which is 25 times 10 to the negative 5th. An amp times a second is the same as a coulomb per second times a second. Seconds go away. So this is coulombs. So that tells us how many coulombs, but that's not how many electrons. Remember, the number of coulombs, or the charge in coulombs, is equal to the number of electrons times that elementary charge. So what we have to do to get the number of electrons is we have to divide that over to this side. 1.6 times 10 to the minus 19. So it looks like the number of electrons is this number here divided by this number of here, which is around 1.6 when you round 10 to the 15. So a huge number of electrons. 10 to the 15 is a lot of zeros. All right, next question. 5. The table below lists various characteristics of 2 metal wires A and B. So what they all have in common, or the two of them have in common, is the same material. So rho is the same. The temperature is the same. And remember, the temperature affects the resistance. The resistance is a function of temperature. Basically, as T goes up, R goes up. But in this case, because they're the same temperature, there's no difference. Now, wire A, so the length of A is 0.1, the length of B is 0.2, and the area of A is 0.01 meters squared. This was, I guess, meters and meters. And the area of B is 0.02 meters squared. And they say the resistance of A is R. Let's just call it RA. And they want to know what's the resistance of B. RA is R. We want to know that. So how does B compare to A? And our resistance is given from this equation. So rho is the same for both of them, so we don't care about that. So R for A is just L of A over A of A times rho. You get some number there. And they called it R because it's in terms of variables. R of B is rho of B, which is the same rho. L of B is twice what L of A is. And A of B is equal to twice of what A of A is. So the 2 and the 2 cancel out, and R of B is just rho L of A divided by A of A, which is the same R. So basically what they're saying in this question is, if you double the length of the wire and you double the area, in this equation, those doublings cancel out, and you get the same resistance. So the answer is just R. Number 6, manufacturer recommends that the longer the extension cord used with an electric drill, the thicker or heavier gauge. Gauge is just a word for sort of the cross-sectional area. And it's weird. The lower the gauge, the bigger the area. The higher the gauge, the smaller the area. The extension cord should be. This recommendation is made because the resistance of the wire varies. Well, the resistance of the wire is rho L over A. So the resistance goes directly with L. R and L, direct relationship. But R and A is an inverse relationship. So if you look at your answers, I think the answer is C. All right, next question, 7. I'll give you the length of a wire is 0.5 meters. They give you the cross-sectional area is 3.14 times 10 to the negative 6 meters squared. And it's found to have a resistance of 2.53 times 10 to the negative 3rd ohms. According to the resistivity chart, the wire could be made of. So when you look in your reference table, they have these resistivities of, aluminum, silver, nichrome, and they give you the numbers. So what you're going to do is you're going to solve for the number and then look it up in the chart. So the equations R equals rho L over A. Plug in your numbers for R, plug in your numbers for L, plug in your number for A. When I did it, I got 1.59 times 10 to the negative 8 ohm meters was what my resistivity was. And when I went to the chart and looked that up, it was silver. Next question is 8. The diameter, if the diameter of a wire were decreased, the electrical resistance. So don't guess. Write down the equation. And they said the diameter were decreased. The diameter, how does that affect these? It doesn't affect L, it affects A. And as the diameter goes down, obviously the area goes down. And it's a square factor. Pi d squared over 4 is what the area is. That's the same as pi r squared. So we could say exactly how much if we knew how the diameter changed, but in this one it's just saying the diameter goes down. So the area goes down. If the area goes down and the length stays the same and rho stays the same, the resistance has to go up because, like we just said, they're inversely related. R is inversely proportional to A. So A goes down, R goes up. So the answer is B, increases. And I'm going to stop.